Welcome to Spring LIB.
To approach this problem with free body diagrams. So from these, this is the free body diagram for block A, and this is for block B. And they're connected by a pulley, of course, so the tension force is the same. So you resolve forces in the x direction for block A, and what you get is that F of t, the tension force, minus mag sine theta, the x component of gravity, is equal to, whoops, not zero, is equal to ma times aa, that acceleration of a, and so that's the first equation. Then you resolve forces in the y direction for block A, and what you get is Fn, normal force, is just ma times g cosine theta, vertical component of gravitational force. And then you resolve forces in the y direction for block B. You have that, so in this case, we'll consider the downward direction as positive. So you have negative Ft plus mbg is equal to mb times an acceleration of b. So Ft is actually mb times g minus ab. Okay, and so we have these three equations, and so let's call this equation 1, this equation 2, and this equation 3. So in equation 1, therefore, we can plug in 3, and so we have ma times a. By the way, a acceleration is due to the rope, and so aa is equal to ab is equal to a. So ma times aa, which is ma times a, is equal to ft, which is mb times g minus a of b, plus minus mag sine theta from the equation. So a times ma plus mb, pulling a terms to the left-hand side, is equal to g times mb minus ma sine theta. And so a is equal to g times mb minus ma sine theta over ma plus mb. So we get 9.8 meters per second squared times 5 kilograms minus 4 kilograms sine 32, okay, over 5 plus 4 kilograms. And so what you get out of this is acceleration is 3.1 meters per second squared. Okay, all right, so that was part A. In part B, we want to find final velocity from kinematic equations. Final velocity squared is equal to initial velocity squared plus 2 times a times height. Initial velocity is 0. So therefore, final velocity is square root of 2 times a times h. A we just found. So it's 2 times 3.1 meters per second squared times h is 0.75 meters. And so, so this is just 2.2 meters per second. Okay, and note that this term here is basically just 2 times a is g times h times mb minus ma sine theta over ma plus mb. And so this is important, and why will become clear in a second. Okay, so we have so this is our expression for velocity, and in part C we're actually doing energy conservation. So initially you have potential energy of potential energy is the only energy. So potential energy is MAGH sine theta for block A's potential energy, and that's equal to kinetic energy for both blocks with the same final velocity. So 1/2 MA plus MB times V squared that we just found, plus potential energy, or we should say plus MB, right, MB times GH. Right. And so there'll be a negative sign here and a negative sign here because they're acting opposite the direction of motion, right? So so essentially, what you have is that V squared is equal to 2 times GH times MB minus MA sine theta over MA plus MB. Therefore, V is the square root of 2GH times MB minus MA sine theta over MA plus MB. And so this is the same exact expression as this right here. Therefore, the velocities will be the exact same.